Okay, third lecture. This one is going to be on C++ stuff. So let's get started with something basic that we should do since we're in a new language. So let's do the classic hello world stuff. So C++, they have special standard include files, and one of them for like printing to the output stream is going to be IO stream, and instead of printf, we now have cout. So let's hit on that cout hello world, and then endl is a way to put a new line and flush the buffer. So cout is the standard output stream, and these arrows here, that's like sort of directing this into the output stream. So this hello world is like flowing into the output stream. That's how you could think of it. And then this comes afterwards. And you could do it like hello space world, and then just put one of those in between. So now we compile C++ files with G++ instead of GCC. So G++ main.cpp, and then let's run it. It says hello world. So if you can see here, I have this using stdcout and using stdndl. Don't worry about that right now. So we'll go over that later. So let's go over classes. So because most people call C++ just C with classes, even though it's not exactly like that, you could sort of think of it like that. So let's make a class, my class. And my class, so every class can have members, and those members can either be variables or functions. So these member variables are stuff that every object of this class can access. So and also there's also now names, or what is it? You can also have different versions of scope for these members. It could either be public, private, or protected. And right now we'll just talk about public and private. So if we have the public keyword, that denotes that everything after this is going to be public for that class. And if you don't have anything for classes, it defaults to everything is just private, so like that. So let's have public, and let's add a variable, int a and int b. So now all objects of my class are gonna have, you're gonna be able to access a and b. So let's make an object, my class, my object, we'll call it. So now we have an object of my class. So so a class is like a sort of like a template for what you make instances of this class of, and those instances are called objects. So we can say my object dot, to access members of a class, you can say, you just put a dot after it, and then you put the name of the member. So dot a, we can say that's 4, and then my object dot b equals 12. And then let's print out, why did I do this? Okay. Let's print out my object dot a plus my object dot b. And let's run this. Boom, and you can see it's 16. So as you can see, we can set these variables by just calling myObject.a, and then we can access them again by calling myObject.a. So we added 4 and 12 together. If this was instead private, that means that you can't see these variables normally. So if we try to compile this, you get errors everywhere because these are private. So you can only see private variables inside of that class's member functions, that own class's functions. So let's go over let's change these back to public, and then let's add a function in. So put a comment that these are member variables. Then let's add member functions. So these are just like normal functions. So let's make something that adds a and b. So int add return sum, let's call that. And it takes in nothing because it's just going to add these a and b. So we can define it right here, or we can define it later down. So let's just define it here right now. So let's return this a plus this b. Okay. So what is this? What is this? So this is a pointer to the instance of the class. So if I did something like let's do this. My object return sum, and then called it. So we're calling this function return sum. Let's run this, see if it works. And as you can see, it returns 16. So what this is, so when we call my object return sum, this is going to be equal to the address of my object. So whenever you're in a member function, there's always going to be this implicit this variable. That's just going to be the address of the object that's calling it. So that would be the same as doing the address of my object, and then like a. So that's what this is effectively doing. So we didn't talk about what this is. This little arrow thing is. You can do this inside of C as well. So what this little arrow thing is, it's for pointers. So let's make a pointer right real quick. So let's make a my class pointer. Object pointer equals the address of my object. So then let's print out object pointer a. And as you can see, the first thing it prints is 4, which is what a is. So what this is doing is this is an easier way to just dereference the pointer and then access an instance of it. So this right here is equivalent to, here, let's comment this part out. This is equivalent to doing the dereferencing followed by a dot. So these two things are equivalent. So if we run this, or compile this and then run it, then you can see it prints out 4 in both cases. This is easier, and that's why it was introduced into C and C++. So here inside this return sum function, we don't need this, but it's a good practice to use this. That way you know what you're referring to. So whenever you can use this, you probably should. That way, if someone's looking at your code, they know this a value. It's a member variable, and not like you might have an input variable called a. And if you just did that a, then someone might not know what you're referring to. So if you're referring to the member variable a, then you'd use this a. If you're referring to this normal a, then you don't have the this. So let's show how we would define. So normally, how you do classes, how you create a class is you'd have a file with that class in it. So let's put this class in its own file, example.h. So the class itself would normally go in the header file, and then the definitions of the class's functions and maybe initializations for its static variables would go in the CPP file. So we'd have this like this. So we'd have the function prototype for return sum here, and then we'd have the actual version in here. So let's just include example.h, and then let's take this. Alright, so if we just leave it like this, it's not going to know what return sum is. It's not going to know return sum is part of a class at all. Even though we're including this, you might just be making another function called return sum, just a random function. So we need to use the scope resolution operator, which is this : which was introduced in C++, and that tells you that this return sum function is part of my class, the class my class. So now in main.cpp we can include example.h, and then all of this stuff should still work. So if we compile, if we compile just this main.cpp file from our previous lecture, you guys should know that we're going to get a linker error because we're not compiling example.cpp. If we had this one uncommented. And yeah, we get a linker error because return sum is not defined because we're not compiling this. So let's add that to our list of files we're compiling. Boom. Boom. Yep, and all this stuff still works. So that's like basics of classes. So let's go over private variables again. Let's make these variables private and have this function public. So now, like I said before, if the variables are private, you won't be able to see them, but functions within that class will. So return sum is within this my class. It's a member function of my class. So that means it can access A and B, even if we can't access A and B here. So if we try to compile this, we're going to get errors in our main.cpp file because we're trying to access A and B. But this example.cpp doesn't have any errors because it can access A and B, even though they're private. So normally what you want to do is try and make your variables private whenever you can, and then have specified functions to set and get those values. So we might have some setters, void set a, int val, void set b, and then we might have some getters, int get a, and then int get b. So then we take these guys and we make sure we have this in the my class scope resolved for that. And then we'll make all these. So for setting A, what we need to do is just say this A equals value. So, and then set B is just B instead of A. And get A, we're just going to return this A. And then get B, we're just going to return this B. So this way we're controlling access to A and B, and just through these setter and getter functions. So now you can only get the values of A and B, or set the values of A and B to these setter and getters, and you can't do it directly, and that's good practice. Because you're defining how you access it. Like maybe you don't want anyone to access A, you might not have this get A function, and that's an alternative to making these guys public. So now, instead of this stuff here, myObject.a equals 4, we're going to do myObject.setA 4, and then myObject.setB 12, and that replaces these two lines. Let's get rid of these object point, yeah. And then if we wanted to say add the two, we might do myObject.getA plus myObject.getB. Set B. Alright, so let's run this and see what we get. So as you can see, we get 16. But we can't do myObject.a anymore because it's private. So that's yeah, what's up?
If you had a whole bunch of these variables, let's say you had like 100 of them,
yeah.
would it be pretty crazy to just be like, hey, here's a generic setter function and give it the name of something? So you're like setting an element of a dictionary or something like that.
Okay, yeah, I see what you're saying. If you had like 100 variables and they're not in an array, they'd probably be in an array. But if they're not in an array, you'd probably wouldn't want to make a setter function and getter function for every single one, like you said. And yeah, you might do something with like in C++, there's maps, and I guess you could use that. There's no
That's a good idea.
Yeah, there's no dictionaries like in Python. But yeah, or you can make them public. I mean, it's up to you, to be honest. But yeah, that's that stuff. Good question. Alright, so now let's go over inheritance. Yeah, let's do that. Alright, so let's say we have a class called animal. Yeah. Yeah, we have an animal class. And all animals can, let's see, they make a noise. Make noise. Yeah. And let's call our make noise function. Let's define that here. Let's say for animals, let's say the noise that they make. Hold on, let's include ISG. Hello. Oh, okay, there we go. All animals can grr. So now let's make our animal object here. Let's call it a gorilla. And then do gorilla.make noise. And let's see what he does. And he gurs. But say we have, so now to illustrate inheritance, we're going to have certain types of animals. So let's have a snake. And let's have a dog. Okay. So how public inheritance works, it's an is a relationship. So what that means, if we did snake inherits from animal, so in order to specify that you're inheriting, you do a colon, and then you do the type of inheritance, and then you do the name of the class you're inheriting from. So we're doing public inheritance from animals. So what that's saying is a snake is a animal. We're going to do the same with a dog. So a dog is also an animal. So now they can override this make noise function. So now you can see why it's useful to have this resolution operator, because there's 3 different make noise functions and we don't know which class, and now we know which class each one belongs to. So snake is gonna hiss and dog is gonna bark. So now we can have our snake, my snake man, and our dog. And if we have the snake make noise, and we have the dog make noise, then you see you can get a hiss and then you can get a bark. Let's say we didn't have this make noise function. So since this snake inherits from an animal, that means all of this animal's public methods are accessible through the snake. So the snake, so we can compile this and we'll see both of these animals just grr. They do grr. That's because they can both access this make noise function from the animal, because everything from the animals is now part of the snake and the dog. And what we did here is we made a make noise function, and since that is more closely that's defined in the snake, and that means it's more closely related to the snake, I guess. So it overrides the previous make noise method. But if we wanted to call the original method, so say we have our snake here, and we wanted to call the original method, what we could do, pretty sure, maybe not, is cast the my snake man to an animal, and then call make noise. Yeah, and as you can see, it makes a grr. So even though it is a snake, and it's making noise, we get the animal make noise because we casted it to an animal. You can cast up easily, so you can cast up no matter what. But you can't necessarily always cast down or to the side. So what I mean by casting up is that you can think of this inheritance like this animal is above the snake, and then something else might inherit this from the snake, and then that's below the snake. And that thing on the bottom has all things above it as part of it. And that's the reason that you can cast it to upwards. So you can cast a snake to an animal because that snake has an animal as part of it. Like when it's stored in memory, even you have the parts for the snake, and then you also have the parts for the animal under the snake as well. So if we took out this animal cast here, and we decided to make noise, you can see we get the hiss. Okay. Yes. So there's that. That's basic inheritance stuff. Let's also go over inheritance with, say, variables. So say the animal had an int a variable, and that was a private variable. And say we wanted to have a get a for the snake. That should be an int. So in this snake method, we're gonna want to return this a, right? Since the snake's an animal, it should be able to access a, right? So let's try it. Get a. And as you can see, we get an error. And what that error says is int animal a is private within this context. So when I said private, even though this animal is a part of the snake, this snake can't access any of this animal's private stuff. Because only animal functions can access that. So if we say we had an animal get a, then we called, I think we're gonna have to cast it. Yeah. So we cast this to an animal. Then we run it. No matching call for call to animal. Int. Oh. Oh, I see. Just need more parentheses. I run it, and it works. Yeah. So if you run this, you can see we get a 3. So I showed here that get a works if you're an animal, and also I showed a way that you can set variables. So you can do int a equals 3. So that's how you initialize, that's one way to initialize variables within a class, but it's not a good way. So let's go over a good way to initialize variables, and that's with constructors. So let's get rid of this get a stuff. Oh, hold on, actually. Let me go over, let me change this back to the snake get a. So another type of specifier besides public and private is protected. So what protected is, it means that any of its variables can now be seen by its children. And by children, I mean anything that inherits from it. So if in this animal-snake relationship, this animal is the parent class and the snake is the child class. It also can be called as this animal is the base class and the snake is the derived class. So now, since A is protected instead of private, snake has access to it, and we should be able to return this A. So let's call my statement I get A. And boom, we get 3. So that's how that works. And what we still can't access it from outside of the class. So if we do my statement.a, it won't work. Alright, so let's go over constructors. So let's not pay attention to snakes and dogs right now. And instead of initializing our variable with int a equals 3, let's make an animal constructor. Constructor. So constructor has a weird way to make it. So it doesn't return anything, so there's no return type. And it only takes in stuff. So it only has the name of the constructor, which has to be the same as the name of the class, and then anything it's returning. So we have our animal constructor, and then we gotta make sure we know it's from the animal type. So we got that. So now this constructor is something that's called whenever we make a new instance of A in a normal way. There's 4 different types of constructors. Yeah. So this is the most basic type. So whenever we make an animal like this, animal, that calls this constructor. So let's say a equals 10, or this a, like I said, good practice. This a equals 10. And let's make this a public. So then let's print my animal.a. And you can see it prints 10. That's because when we created this animal, a got set to 10. So you can also take stuff in for the constructor. So let's make the constructor take in an integer to value. Then we gotta make sure we mirror that. And then we can say this a equals value. So there are 2 different ways in C++ to pass in values. So we can do this. We can use normal parentheses. So if we run this, we get 20 because we set it to 20. Or we can use curly braces. And I personally prefer to use curly braces because that makes it clear that we're not calling a function. We're initializing this animal to that value. So yeah. Then there's, instead of setting a to value in here, inside of the body of the function, we can do it inside of the initializer list. So initializer list has a colon after the name of the function, and then you can say, so now you can have initialize the different member variables for this class. So we have a, and then we're going to set that equal to value. So this is the same thing as saying this a equals val, except that it's called before, except this initialization is done before we even enter the body of this function. And that's important for inheritance. So let's run this. 20. And here you see we use parentheses. I also prefer to use curly braces here when we initialize a. So this should also work. A 20. So you should always use initializer lists when you can, because that makes it clear that you're initializing some variables to something. Yep. And okay, so we can also have default values. This is done in a lot of programming languages, so we can say int val equals 5. So by default, this value that gets passed in is going to be 5. So that means if we don't pass in anything, it's just going to default to 5. So let's run it. I'm passing in 20, and you see it prints 20. Now let's run it without passing in, without passing in anything. Boom, prints 5, because it defaulted to 5. Yep.
The neat little command line thing
Yeah.
is right after you do that G++ line, you can put and
Yeah.
and then do the next line. So that's just one command.
Gotcha. Cool. Yeah, thank you. Okay. Yeah. Back to what we were talking about. So let's go over inheritance and constructors. So let's have our snake here. Let's have our snake constructor. So it's just going to be named snake. And let's make it not do anything. Yeah, let's make a snake variable. Alright. Oh, and one important thing to note is that in the initializer list, you can't use this. So you just use the name of the variable. Okay. So now we have our snakey boy, snake constructor. So let's print in the body, hold on, in the body of the paragraph when this constructor is called. Animal constructor called. Snake constructor called. Okay, and now let's make a snake. Oh yeah, let's initialize snake R is 3. So now if we made a snake object, let's see the order that these constructors get called in. Oh. Yeah, okay. So as you can see, when we make a snake object, the animal constructor gets called first, and then the snake constructor gets called. So for inheritance, the base classes constructor will always get called before the derived classes constructor gets called. So that's something important to keep in mind if you're doing anything with that. Like maybe if you depended on this being called before this, just know that this one's gonna get called first. Okay. Now let's go into Oh, and then something interesting about C++ that some other programming languages don't have is that you can inherit from multiple classes. So the snake can inherit from an animal or something else if you had another class. And then it would have all the public and protected stuff from both of those classes as part of its class now. Okay. So now I guess we can talk about the other types of constructors. But it's not. Yeah, I guess. Okay. So there's the assignment operator constructor. It's not a constructor. There's the assignment operator that returns an animal reference operator equals. It takes in. Oh, we should go over references first. Yeah, actually, let's do that. So our animal, let's have the function change that variable. So it's going to take an int reference variable. So in C, you don't have this. This type of data type, this int and then a asterisk after it. So what this is this is a reference. So let's just give an example. Let's make this change variable 1 and then change variable 2. One of them is going to take in a reference, the other will not. And these are both animals. And all they're going to do is going to say variable equals 434. Okay. Let's actually change the reference. And this is going to be value. Okay. So let's make an animal. Animal. Let's do animal dot change variable reference. So let's make a quick variable int var 1 equals 33 and var 2 equals 33. Okay, and then we're going to pass in var 1 into change variable reference, and then change variable value is we're going to pass in var 2. Then we're going to print out both those down here. Var 1 equals Alright, so let's run this and see what happens. So as you can see, we have my var1 is going to be 434 after this function call, but my var2 is going to be 33. So the reason that is because here we're passing variable as a reference, change variable reference, and here we're passing it by value. So when you pass it by value, you're making a copy of that variable and passing it in here. But when you're passing it by reference, you're taking what that actual variable is in memory and you're passing that in. And how we do this in if we wanted to modify the variable being passed in C, what we do is we pass a pointer So let's show that method real quick. So what we do is we take in a pointer, Alright, and then what we do is we do variable pointer, dereference it, say it equals 424. So now if we hit a third one, we did animal object change variable pointer. Then we pass the average, address of my variable 3. And you print it out here. You can see that my variable 3 has also changed to 434. But you have to go through all the trouble of passing the address of it and then dereferencing that address to get the actual data there, to change that data. Now in C++, you can just pass a reference, and it's an easy way to change something that's being passed in. Okay, coolios. Let's go back to assignment operator. So the assignment operator is going to return an animal reference. Operator equals, and it's going to take in a const animal reference. So what we're doing here is we have this weird operator equals here. So we're overloading the equal sign operator. We could also change this to operator plus, and that would be a way to override the plus operator. But right now, another sort of form of constructor, even though it's not really a constructor, is the assignment operator. So what this assignment operator is, takes in a reference to another animal that is constant, and we call it RHS. So that's the right hand side. So that's what value is going to be on the right hand side of the equal sign, and what we're going to be returning is an animal reference. So let's put that in here. And the only types of functions that you can use this initializer list is for constructors. So I'd get an error if I tried to do it on something like this type of function. So let's say return RHS. Okay. So what we would do okay, so what we do, say we had an animal bar. So we do this animal bar this animal bar and equals RHS.animal bar. Boom. And you return the dereference this. So this is just a way of setting the animal variable for this equal to the right hand side's animal variable, and then we're just going to return this. So let's print out the assignment operator. It's called. So let's give an example of when this would happen. So if we had an animal object, and let's say that animal object dot animal var equals 23, and made another animal animal copy, another let's just call it a goose. And we say equals animal object. That's going to trigger the assignment operator. And let's print out goose.animal var. So it's because of okay. I guess when this is when the okay. So I think what's happening here is the assignment operator actually does get called, but what it's doing is it's doing optimization to make it seem like just the constructor is called. There's some flags that I can set to not make this happen, but I'm not sure what they are. But here is an example of when the assignment operator wouldn't get called. Another example is if we did goose equals animal object. Then you can see that we get animal operator called. Here it won't optimize that away because it's not doing it on the same line when it's created. Actually, maybe the assignment operator doesn't get called there. Maybe the copy constructor does. Okay, one of them does. So let's go into the third type of constructor, the copy constructor. So we now have an animal. Oh yeah, the copy constructor does get called there before. Const animal. So this is gonna be the same type of wording as a normal constructor, except instead of taking in maybe like a variable or nothing, we have to take in this const animal reference. So boom, and then all you'd want to do is say this var equals obj.animal var. Then let's print out that the copy constructor was called. Yeah. So as you can see, this is just a normal constructor that takes in an animal object. So in order to show that, we can have the goose take an animal object. Boom, animal constructor is called for this guy, and then the copy constructor is called for the goose. If we set equal to, I'm pretty sure, yeah, that this won't do the assignment operator, this will do the copy constructor. And yeah, it does the copy constructor. So even though it has an equal sign here, it's gonna do the copy constructor. So so there's something called the rule of three, which is these two constructors, and then there's also something called the destructor, which is the little tilde, and then the animal, name animal, and destructors don't take in anything. And Okay, and let's just print destructor called. So let's run this. As you can see, the destructor is called twice. So the destructor, so the constructor is called whenever an object is made, and the destructor is called whenever the object is destroyed. So these objects are destroyed when they fall out of scope, and they fall out of scope when you exit the main function. So basically, when the program's over, these guys get destroyed, and that's what the destructor is called. So there's something called the rule of three, which is these three guys here: assignment operator, the copy constructor, and the destructor. And these are all functions that you want to implement when you're dealing with dynamic memory, which is something we haven't really talked about, but it's a way to allocate memory when the program is running. So maybe you have an array here as your member variable for this animal class, and you create that memory in the constructor. Well, when you do a copy of that, you're just gonna copy the pointer if you're allocating memory the basic way. Then it's gonna do something called a shallow copy instead of a deep copy, something that I'm not gonna go over right now. And in order to do a deep copy, that you're gonna need the assignment operator and the copy constructor, so that whenever you make a variable as a copy of that other, or an object as a copy of another object, you're copying the actual data. You're creating an actual extra allocating memory for that data, actually, instead of just copying the location to that data. And then the destructor is a way so that if one of the objects falls out of scope, the memory that it's pointing to gets destroyed, and you will have memory leaks. Okay, so I guess we'll go over polymorphism real quick, and then that's gonna be it for today. So let's just delete all this real quick. Get rid of all these guys. Alright. So let's have a function called do something. Alright, let's call it say something. Alright, let's go back to make those. Okay. So while I'm doing this, I just wanted to mention that C++ is definitely not something that you can learn in a few days. You definitely have to practice and do a lot of projects in C++, because it's pretty complicated. This is just the very, very basics of C++. There's much more complicated stuff when you go into the standard libraries, and you get more in depth with complex classes and data structures and everything. Okay, but anyways, let's have our animal go grr again, and our snake do a hiss. Alright, so like we said before, we make a snake. And we do my snake would make noise. It's gonna call the hiss because this is the snake function. It's overriding the animal function. But let's say we got into something. Let's say we had a pointer, an animal pointer, and my animal pointer equals the address of my snake pointer. So, like I said before, you can upcast all when you're dealing with classes because this so upcast. What I mean by that is cast a snake to an animal. And you can do that because this snake class has this animal class a part of it. So that's what allows us to make a animal pointer. So it's gonna point to memory at an animal object. Because this snake object has an animal object that's a part of it. So we can have our my animal pointer, and then we can have my animal pointer call make noise. And like I spoke about before, we're using this little arrow guy, which is just the easy way to dereference and then call a function. So if we run this, it's going to make the grr sound. So what polymorphism does is it allows this animal pointer to realize that it's not pointing to just an animal, it's pointing to an actual snake. And we want it to call the snake make noise function. So in order to do that, we need to have this animal function be a virtual function. And then what we normally do, what's good practice in order to show that we're overriding a virtual function is we'd have this override operator here, or this override keyword here. You don't need it though. So now, if we call my animal pointer make noise, it'll hiss because even though it's an animal pointer, it can see that this isn't just an animal, it's an actual snake. So it can look at the inside the vtable, and it sees that this function is overridden by the snake. So it's going to call the snake function. So how would this be useful? Let's make a dog. Let's show it off. So we're also going to have a make noise for the dog. It's going to override the animals make noise. So there's our dog. Okay, and let's say we have an array of animals pointers, an array of animal pointers, and we have our snake, and we also have our dog. So let's have animal array 0 gonna be the address of the snake. So the first element in our array is gonna be the address of the snake, and then the second element is gonna be the address of our dog. So then we can loop through this array with our for loop, and then call animal array I make noise. So this is a way to store all of our different types of animals, our snakes, our dogs. We might have other animals like turtles or something else. And this is a way to keep all of them in one place, is to have animal pointers to all of them. And then in order to access the functions that we want to actually call from each of those different animals is we can have polymorphism. So now if we run this, it's going to make the correct noise for each of the animals. If we had our dog do a bark. Yep. So as you can see, our snake hisses and our dog barks. If we didn't have polymorphism, then what we get is we just get two gers because it thinks it's just pointing to an animal. So that's basics of polymorphism. It's a way for you to override functionality from parent classes in the child class functions. And it's definitely an important topic, one of the most important topics in C++, and it's something you should become much more familiar with if you can. Alright, and that's all I'm going to talk about for today, unless anyone has any questions.
Oops. Hi.
Yeah.
I'm a bit curious how this connects to the source code for the project.
Oh, for the robotics stuff?
Mm-hmm.
That's because uh, the people that have written the code for that have made use. It's because we write C++ for that type of code, and we make use of all these. So I'm just trying to teach people who don't know C++ some of the stuff that we use inside the project, so that when they see it for the first time, they're not like completely bewildered.
Yeah.
Yeah.
Trying to get at is there kind of this, but kind of a demo of how the project code works together as the next step.
So like, um, what do you mean? Sorry.
So when trying to work on a software project, sometimes you just see like a whole bunch of files and code, and like understanding the structure is a hurdle, and how some of the various functions work, what can be kind of ignored as like, hey, we solved this problem, it's done, it's just a black box. This is where we need help on that sort of thing to better understand the code infrastructure that you guys have set up.
Okay, I got it. So you'd probably want to talk to whatever team you want to join. There's telemetry, there's auxiliary systems, and then there's like the website team, sort of. So you probably want to talk to whoever is the system lead for that, and uh, we have everyone should have documented all their code, and the system lead should be knowledgeable about like what needs to be done. Right now, all the code on the GitHub is on the GitHub. If you want a link to that, I can get you one.
Yeah, that would be great.
Do you have a GitHub account?
Yep, it's same username.
Like, alright, send you an invite.
I put the link to the GitHub. Oh, you're sending me an invite? Okay, never mind.
Yeah. So yeah, I worked on telemetry. So if you have any questions about telemetry, I could help you out with that. But the README has some pretty like a summary of like what's what, pretty much.
Nice, thank you, Noah.
Yeah.
Yeah, I'm definitely interested in telemetry. I was talking, I think, to Samuel earlier about you either doing helping with the telemetry or battery management system, and my intuition is that a lot of these systems are very interconnected, and understanding the project as a whole to some degree is also really valuable.
Yeah, for sure. I say so. But yeah, I'm not doing anything that's like too related to the project. I'm just trying to teach C++ right now.